first, I'd like to say some of the facts of Joakim's biography, and then also what I think about him. Joakim Nivre is a professor of computational linguistics at Uppsala University, and also he's senior researcher at Research Institute of Sweden. He holds a PhD in general linguistics from the University of Gothenburg and PhD in computer science from Växjö University. So he's interested in data-driven methods in natural language processing, especially morphosyntax and syntax, also semantics. It should be noted that he's one of the main developers of the transition-based approach in parsing, especially syntactic dependency parsing. And the MALC parser that was the result of this is very much used even now. I mean, in the era of large language models. Lately, one of the really major initiatives is the Universal Dependencies project. Yesterday at the tutorial, I didn't have the time to say more, but I told you that today you will listen more about this. At the moment, there are, I think, 180 language, 200 and something, 3 banks and 160 languages. I mean, this initiative, as you see, it is 10-year-old already, very mature, and a big one. I think it is the state of the art at the moment for dependency resources and dependency parsing as well. He worked in Google, and also he was president of the Association for Computational Linguistics in 2017. And so I can continue and continue, but I prefer to stop and to say that to me, Joakim and his team are also one of the best typologists. They developed into typologists with so many languages. And I remember when I met him years ago in one of the editions of the workshop for 3 banks and linguistic theories that started early 2000 year. Then he had a paper called What Kind of Trees Can Grow in Swedish Soil. So I think that we saw many, many nice trees can grow there and also in other soils. But we also saw that during these years that also great researchers can grow in this Swedish soil. One of them is presenting now. So Joakim, you have the floor.
Thank you. Thank you so much, Petja, for that very, very kind introduction. I'm really delighted to be here talking to you about universal dependencies. My only regret is that I am also sorry that I couldn't be there in person, but unfortunately it wasn't possible this time. So hopefully some other time. So let's start from the beginning. So what is universal dependencies? Well, Petja already mentioned a little bit about it in our introduction, but if you go to the Universal Dependencies website, you can learn that Universal Dependencies, or UD for short, is a project developing cross-linguistically consistent tree bank annotation for many languages with the goal of facilitating multilingual parser development, cross-lingual learning, and parsing research from a language typology perspective. And I think this is a fairly accurate description of the project at the time when it started, but it has been 10 years and it has evolved in a number of ways. So I think it's fair to say that today UD is not only a project, it is an annotation scheme, a data repository, and arguably a kind of research community. And in this presentation, I want to touch on each of these 3 aspects in turn and give my sort of reflections on how things have developed over these 10 years. But before we go into that, I cannot resist the temptation to take a little stroll down memory lane and tell you the story of how it all started. And I think different people who are involved in the initiative would maybe tell this story in different ways. But for me, this all started in 2006 with the first Connell shared task on multilingual dependency parsing. And I want to take this opportunity to acknowledge the huge debt that the community owed to these four people, the organizers of the first shared task, who managed to pull together at the time dependency tree bank for no less than 13 different languages, which was an amazing achievement at the time. And not only that, they also came up with this standardized data format called the Connell X format for representing these that became a de facto standard for years and years. Now, at about the same time in California, our colleagues, in particular Marie de Manef and Chris Manning, released the first version of the Stanford Dependencies, which at the time was not really an annotation scheme. It was rather something like a front end to a syntactic parser, because in those days, at least for English, most of the parsers were based on constituency, not dependency. But people who developed NLP applications often found it more useful to have dependency representation. So they came up with this scheme as a way of taking the output of a constituency parser and converting it to dependencies. Now, a year later, my colleague Ryan McDonald and I wanted to do an error analysis based on the Connell shared task. We wanted to compare parsers across languages. And one of the things we wanted to do was to see how well they dealt with different types of linguistic constructions. So we tried to compare linguistic structures across languages. And it turned out to be extremely difficult because even though there was a standardized data format, at that point in time, every tree bank had pretty much its own annotation guidelines. In the end, we managed to, after reading all the guidelines carefully, come up with some very broad categories. You can see part of speech categories in this slide if you can read it, but it was very, and that we could map to, but it was quite fuzzy and sort of imprecise. Now, a few years later, my colleague Daniel Zeman at Charles University in Prague approached this problem in a more principled way and came up with the interlingua the interset interlingua, which, as you can see in this slide, is meant to be a nearly universal set of features that can be used to map between different part-of-speech tagging systems. Now, a few years later, Google released their own version of this, the Google Universal Part-of-Speech Tag, which was actually based or started with the mapping that Ryan and I came up with for the error analysis in 2007. Now, meanwhile, in Prague, Dan and his colleagues had taken this one step further and started harmonizing not only part-of-speech tags, but also the dependency annotation, essentially by converting many tree banks to a version of the Prague dependency tree bank annotation scheme. Now, the year after, again in collaboration with Ryan and others at Google, I was involved in an initiative to release what we called the Universal Dependency Tree Banks, not to be confused with UD itself. And we were very happy to be awarded an ACL Test of Time award last year for this paper, where we tried to propose a sort of a common standard based on the Google Universal Part-of-Speech Tags and a version of Stanford dependencies. Now, this immediately prompted a reaction from our colleagues in Stanford, who liked the idea of a universal scheme, but didn't like some of our decisions. So they came up with an alternative proposal and eventually even hijacked me into becoming an author of this paper, contradicting myself, essentially. And this was the point at which we said, enough is enough. Let's stop multiplying these standards that are almost the same but slightly different. Let's all get together and agree on a single standard. So we had this kickoff meeting in Gothenburg in 2014, and then released the first version of the Universal Dependencies Guidelines in 2014, which then was based on revised and extended versions of the Universal Stanford Dependencies, the Google Universal Part-of-Speech Tags, and the interset system of morphological features. Now, in January the following years, we had the first release of tree banks for 10 languages, so fairly modest at the start. In 2016, we released the second version of the guidelines, where we tried to fix some of the most obvious mistakes in the first version. And then 2017 turned out to be a very productive year for universal dependencies. So the slide I'm showing here is from the closing session of the first UD workshop, which is a workshop series, workshop that has been held annually ever since. We also had a tutorial at EACL in Valencia, and more importantly, we organized the first of a new series of Connell shared tasks on multilingual dependency parsing, very much in the same spirit as the original shared task from 2006 that it all started with, but this time with data sets that were standardized not only with respect to the data format, but also with respect to the annotation scheme, therefore hopefully allowing more meaningful comparisons across languages. Now, here is an illustration by my colleague Philip Ginter trying to show the impact that these shared tasks had on parsing for many languages. I realize that this is too small to read, but the idea is that on the x-axis, you have the amount of data that is available for a language. On the y-axis, you have the best achieved parsing accuracy for that language, and every arrow here is a language. So what you can see is essentially that all languages improved on one of these dimensions, and the majority on both of them. In 2020, we reached the important milestone of having more than 100 languages in UD, and we also saw the first of a second series of shared tasks, this time on parsing into enhanced dependencies, which is this richer version of the syntactic annotation that exists for a subset of languages in UD. And finally, in 2022, we introduced a new policy for making updates to the annotation scheme without necessarily changing the entire version through a system that we call amendments and clarifications. All right, so after this sort of personal history of UD, if you like, I want to talk first about the UD as an annotation scheme, which obviously is very central because the whole effort is about trying to achieve cross-linguistically consistent morphosyntactic annotation so that we can make the kind of meaningful comparisons across languages that we couldn't do in 2006 or 2007, and therefore thereby, I should say, support multilingual research in NLP and linguistics. We decided to build the system on common usage and existing de facto standards at the time, and I think sort of the development has shown that this was a wise decision, because I doubt that adoption would have been as wide as it has been if we had not made this choice. Another point that is perhaps not emphasized as much as it should be is the fact that UD was never meant to replace all other annotation schemes. It was meant to be a complement to language-specific schemes, because the goal of making cross-linguistic comparisons by necessity implies that you have to abstract over some of the finer details of individual languages. So if you're primarily interested in all these details of a single language, then UD may not be the best choice for annotation. But as soon as you want to make comparisons to other languages, especially languages that are maybe typologically different, then hopefully UD should be helpful. Now, the basic philosophy of UD has often been summed up in this slogan: maximize parallelism between languages, but don't overdo it. And what we mean by that is that we want to bring out things that are similar and parallel in languages, and not obscure them by having different annotation categories or different guidelines for their annotations. But of course, we shouldn't go too far. We shouldn't make languages look parallel when they in fact aren't. So the idea is to aim for something like a universal taxonomy with language-specific elaboration. Now, a few basic design principles. One was the choice to base UD on a dependency-based view of syntax. And this was, to a large extent, an opportunistic choice. Dependency was, at the time when we started, already widely used in practical NLP systems, and for all languages except possibly English was sort of the dominant paradigm. It was also available in tree banks for a fairly large number of languages, so we had hopes that they could relatively easily be converted to the new standard. The second important design principle is the adoption of a lexicalist view, which in this context essentially means that we take the basic annotation units to be words. Words have morphological structure and morphological properties, and those should be captured in a morphological annotation layer. Words also enter into syntactic relations, and those should be captured in a syntactic annotation layer. But we assume a fairly sort of strict division between these two layers. But it's important to also note that when I talk about words here, I mean something like syntactic words or morphosyntactic words, not orthographic words or phonological words. And this means that we have to take care when segmenting sentences into words in a language. So before I move on to the actual sort of annotation, I want to say a few words about this problem of word segmentation, which has turned out to be one of the most challenging of the whole endeavor. That is to come up with good criteria for segmenting sentences into words across typologically different languages. And we still don't have a completely satisfactory solution to this, but we do provide sort of some rules of thumb to help people make reasonable decisions here. So on the one hand, we say that a word should always have a single part of speech tag. So if you look at some segment and say, that's an article, but there's also a preposition in there, then you're probably looking at something that is the fusion of two words and that maybe should be segmented into two words for the purpose of annotation. On the other hand, every word should have a real syntactic relation to some other word. So if all you can say about a segment is that it is an inflection of some stem, then it's probably not a word, but an affix. So but in order to make this more transparent, UD offers the possibility to represent segmentation at two levels, a basic orthographic segmentation level, which for many but not all languages can be achieved essentially by relying on white space and punctuation. But then in addition to that, this level of syntactic words, which is a more linguistically informed notion that we use for annotation. So just to give you a couple of examples of what this could mean in practice, in French, there is a token ou, which linguistically speaking is a fusion of the preposition a and the definite article, the plural definite article les. And for the purpose of annotation, we can segment that into two words so that we can assign them different functions. Similarly, in Spanish, dámelo is written as a single orthographic token, but linguistically it's a verb and two pronouns, meaning give it to me or give me it, literally. And again, to get a full syntactic analysis, we may want to segment them into multiple words. If we move to a language like Hebrew, it gets even more complex because Hebrew still uses spaces between words, but it tends to put more linguistic material between the spaces than in most European languages. So if we read this token on the left, it means something like "and that in the sun." So it's actually, linguistically speaking, a conjunction, a pronoun, a preposition, an article, and then a noun. And again, for the purpose of annotation in the Hebrew tree bank, this is segmented into 5 words. And of course, there are languages that don't use spaces at all in their writing system, like Japanese. So this string of characters meaning Osaka Convention Center also needs to be segmented into words before we can start annotation. Now, so moving on then to the morphological annotation layer, assuming that we have sort of a word segmentation, I'm going to use a French example here for illustration. Le chat chasse les chiens. The cat chases the dogs. We can assign to each word a lemma representing the base form. Now, lemmas are language specific, so UD doesn't have a lot to say about how they should be, what they should look like. But then we want to assign also to each word a part-of-speech tag representing its grammatical class. And this is where we use this inventory of part-of-speech tag that is a revised and extended version of the Google Universal Part-of-Speech tag set, which currently contains 17 categories. They can be broadly divided into open classes like adjective, adverbs, nouns, and verbs, and a few others, and closed class like adpositions, which generalizes over prepositions and postpositions, conjunctions, coordinating and subordinating, auxiliaries, pronouns, and so on. And then a few special categories for things like punctuation and symbols. And the X category is sort of is a category that can be used if you really have no idea what a word is. Now, it's important to note that this is a fixed inventory. So you cannot invent new part-of-speech tags for a specific language, but all languages don't have to use all the categories. So if a language, for example, does not have a grammaticalized distinction between common nouns and proper nouns, they don't need to use both the noun tag and the proper noun tag. They can use simply the noun tag in that case. Now, these part-of-speech tags provide you with what for many languages is a very coarse-grained classification, especially if it's a morphologically rich language. So in addition to this, we also have features that represent lexical or grammatical properties, either of a lemma or of a particular inflected form. So in the case of French, nouns would typically have features for gender and number, and verbs would have, in addition, features for mood, tense, and so on. Now, here we also have an inventory of universal features, and for each of these features, there is also an inventory of possible values. But unlike the part-of-speech tag set, this is not a fixed inventory, because here we realize that as new languages get added to UD, the need for new features or for new values of existing features may appear. So here it's you can always sort of add new features or values. And if they turn out to be useful for more than one language, they get incorporated into the inventory of universal features and values. All right, so far about the morphological layer. Let me turn next to the syntactic layer, which is the second layer of the annotation. And I'm going to use an English example for this section. The cat could have chased all the dogs down the street. And I already said that UD, as the name implies, assumes a type of dependency representation of syntax. But it is a rather special version of dependency, which actually not all dependency grammarians are happy about. So the basic idea is that we start by connecting content words by syntactic relations. So in a sentence like this, the sort of the most central word is the main verb chased, which has 3 direct dependents. There is a nominal subject headed by the word cat, there is a direct object headed by the word dogs, and there is an oblique or locative modifier headed by the word street. Function words are then essentially attached to the content word that they modify. So determiners go with nouns, auxiliaries go with verbs, And even a preposition like down in this example is essentially treated as a case marker on the noun rather than as the head of a prepositional phrase, which is perhaps the most controversial part of UD syntax. Now, if you want to include punctuation as well, we have guidelines for that too, but I won't go into them here. But I want to spend just one more minute on explaining and motivating why we draw the syntactic representations in this way. And I'm using here again an English example. The dog was chased by the cat, with a direct translation into Swedish and Czech. And the point is, coming back to this slogan of making languages parallel, is that if we focus on direct relations between, in this case, verbs and nouns, then we actually have a parallel syntactic structure for these three sentences in three different languages. And I think most people would agree that there is a parallelism here. There is a passive predicate, there is a nominal subject, and there is an oblique agent modifier expressing the agent of the action. What differs between these languages is the way that different grammatical categories are encoded in the language. So, for example, definiteness is encoded in English with a separate function word, the article the. In Swedish, it is an inflectional category on the noun, so there is an affix on the noun marking definiteness. And in Czech, there is nothing because definiteness is not a grammaticalized category in Czech. Similarly, the passive predicate is a periphrastic construction in English. It is, again, a morphological inflection in Swedish. At least that's one of the options that exist in Swedish. And in Czech, it's arguably a combination of the two, because there is an auxiliary, but the particular participle form is unique to the passive. And finally, the agent phrase, or the oblique modifier, is encoded with a preposition in Swedish and English, but with the instrumental case, so a morphological case inflection in Czech. All right. So in order to classify these syntactic relations, we have also have a taxonomy of currently 37 universal relations. And this taxonomy is organized by two main principles. The first is the assumption that in all languages, we expect to find three major types of structures: clauses, which are organized around a predicate and its dependents. Predicate are often verbs, but they don't have to be. Secondly, nominals, which are nominal expressions whose perhaps primary use in language is to refer to entities. And then modifier words like adjectives and adverbs that can modify either nominals or predicates or clauses. The second principle is a distinction between, and this is at the clause level for dependents or predicates, between core arguments, essentially subjects and objects on the one hand, and all other dependents on the other. We do allow language-specific subtypes, so there is some flexibility here, although they are optional. But the idea is that if you want to introduce a special relation for a particular distinction in a language, it always has to be a subtype of a universal relation, so that for the purposes of cross-linguistic comparison, you can back off to the universal relation. I should say, and I've sort of mentioned this already, that the syntactic annotation comes in two versions, the so-called basic and the enhanced dependencies. Basic dependencies are the ones that I've been showing you so far. They always form a simple tree, although it can be a non-projective tree. The enhanced dependencies have additional dependencies to capture relations that are only implicit in the basic relations, like control relations or propagations over coordinations. And in a few limited cases, they even can have empty nodes in cases of ellipses like gapping. Now, the enhanced representations, as I mentioned, are only available so far for a subset of the UD languages, and I won't go into them further now. So here is a table showing the 37 different relations, and I won't have time to go through this in detail, but let me just sort of explain to you how this table is organized according to the two main principles that I just mentioned. So in the first row, we have core arguments or core dependents of predicates at the clause level. In the second row, we have non-core dependents of predicates. And in the third row, we have dependents of nominals. And then we have 4 different columns for different forms that these dependents can take. So they can be nominals, they can be clauses, and those are the only 2 options for core arguments. They can be modifier words like adjectives or adverbs, or they can be function words, which as I already explained, get a special treatment in UD. In the bottom row, we have everything else that is needed to do full tree bank annotation. So special relations for coordination, for headless constructions, which we recognize even though it's a dependency-based view of syntax, loose, connected, like parataxis and so on, and a small set of special relations that are needed for things like disfluencies in speech or typographic errors in writing, or the orphan relation, which is for cases of ellipsis. All right, so that sort of concludes the tour of the annotation scheme. So I now want to move to the second aspect that I mentioned in the beginning, namely UD as a data repository. So this is a repository of tree banks or morphosyntactically annotated corpora, which has grown at a rate that none of us could imagine when we started the project. And we are extremely grateful for all the contributions that we've got. So in the latest version released in May this year, we have data sets for 161 languages representing over 30 language families and nearly 300 tree banks, because many languages by now have more than one tree bank. This is altogether about 2 million sentences or 32 million words, which of course is not a lot if you compare to the enormous data sets that are used to train large language models, but we have to remember that this is linguistically annotated data sets. And this is the most important point, this has been possible only thanks to the amazing contributions from over 600 researchers around the world who have found it worth spending time and effort at contributing to this repository, for which we are immensely grateful. Now, just to give you a little glimpse of what languages are actually in here. So in terms of language families, it's inevitable that it's skewed towards Indo-European, but it has become considerably more balanced over time. So in the first release, we had 80% Indo-European languages. In the latest release, we have 46%. And we hope that, and we conceive that by now, at least a few other language families are starting to have good representations. Similarly, if we peek inside the Indo-European family, we see certain branches dominating, in particular Slavic, Germanic, Romance. But again, it has become more balanced over time, and we now see representation also for many other branches. So we hope that this will continue. Now, one thing that you cannot see from a diagram like this is the amount of data that is available in each tree bank or for each language. And that is something where the picture is maybe not quite as rosy, because here is a diagram showing the sizes of all the tree banks on a logarithmic scale. And what we can see is that, yes, there are a few really big ones that contain more than 1 million words, but the overwhelming majority of tree banks are much smaller. And in fact, the median size in the latest release is about 23,000 words. Now, these many small tree banks can still be extremely valuable. In many cases, they are the first existing annotated corpus for a language. But of course, for some of the original use cases of UD, like training and evaluating parsers, they may be less useful. So one of the most important challenges that UD faces going forward is to make sure that we do not only get data for more languages, which is always welcome, but that we can also get more data for the languages that already exist to make these resources even more useful. Now, I want to end by saying a few words about what I called the UD community at the beginning. The UD community is very much a self-organizing system, but at the center you have the Universal Guidelines Group, which is this group of 17 people, the majority of whom were also founders of the project and who are responsible for maintaining the Universal Guidelines, but also for data validation and data releases. And here I want to again acknowledge a huge debt that we all know to Daniel Zeman, my colleague at Charles University, who puts in an enormous effort at making sure that the whole system with validation and data releases actually works twice a year. Now, in addition to the Universal Guidelines Group, we have the equally important and much larger group of tree bank developers. These are the 600 plus people that I already mentioned, and who are all responsible for their own data sets, but also importantly for the language-specific documentation that needs to complement the universal documentation. But it doesn't end there. We also have another growing group of people, which are the tree bank users. So researchers and maybe developers that make use of these resources for research or for technical development. And until recently, at least I had a much vaguer idea of what goes on in this larger community. So as we were approaching the 10-year anniversary, I decided that I wanted to learn more about this. So I made a literature survey with the help of Google Scholar. So everything has to be taken with a pinch of salt. But still, I searched for papers that contain the exact phrase universal dependencies, which turned out to be a lot more precise than I had thought. And this, first of all, gave me some publication statistics. And of course, we know the exact numbers cannot be trusted, but I do think the overall trends can be trusted. So we've seen sort of a steady increase in the number of papers that refer to universal dependencies each year. And now we're probably starting to see the beginning of a plateau or maybe even decline, who knows. But more interestingly, what are all these papers about? So I couldn't read them all, but I went through a sample of 20% from each year and looked at least the title and abstract and tried to classify them into broad categories of research. And I won't have time to go through this in detail, but I just want to point out that if we look at the bottom three categories, the blue, green, and yellow, which are papers about universal guidelines, UD or other, papers about language-specific guidelines or tree banks, and papers about morphosyntactic and semantic parsing. You could say that this is sort of the cases that UD was originally designed for. And we see that for most of these 10 years, that have been the dominant type of research, in particular parsing, boosted by the various shared tasks that were organized. But we see that in recent years, we also see increasing representation of, first of all, downstream NLP tasks, which is to some extent maybe surprising given the recent developments in the field where people do not necessarily use parsers to develop downstream systems anymore, but also interestingly, linguistic research, in particular, I would say typological research, where people make use of these resources to study languages. And then this small but interesting and apparently growing category of making use of linguistic resources to make sense of what NLP models, in particular large language models, actually learn about language. So we think it's, on the one hand, we are aware that the field of NLP has been sort of, to some extent, been moving away, or maybe to a large extent, been moving away from the use of linguistically annotated resources. But we find it reassuring that it seems that people find other interesting uses of these resources. So it's time to sum up. I think on the positive side, we have been very fortunate to see an amazing growth in terms of contributors in tree banks. And I think this survey has shown that data sets are, or at least have been, widely used for research in NLP and linguistics. But we should also acknowledge that there are challenges. Data sets are uneven in terms of quality and quantity. I focused on the quantity in this presentation, but anyone who has been actively working with the resources are aware that the quality or consistency of annotation also varies a bit between different data sets. We think that the annotation scheme, and perhaps particularly the documentation, the guidelines, can be improved to better support people's efforts to annotate different languages. And it's also clear that relevance to the research community cannot be taken for granted. I will end here so that we have at least a few minutes for questions. And I want to end the way I always end when giving a presentation on UD, by thanking all the UD contributors, without whom UD literally would not exist. Thank you.